Hi everyone. In this video we're going to start to talk about section 1.1, which is solving linear equations. So there are a few terms that we need to talk about in order to be able to solve a linear equation. Now, most of you are probably familiar with solving the simplest, the most simple linear equations, and probably also some of the more complicated ones. So this should be information that you sort of have in the back of your head, but if not, that's fine too, okay? But we're going to take a more technical approach here than maybe you're used to, and so some of these definitions may seem sort of weird. An equation in one variable is a statement in which two expressions, at least one containing the variable, are set equal. Okay, so when I say equation, what I mean is this. Okay, these are all examples of equations. So I also talk about the sides of the equation. Okay, and each side of the equation is the expression on either side of the equal sign. Okay, so side, left side, right side. Because the equation is a statement, it must be either true or false. The values of the equation that make the statement true are called the solutions. Okay, so these are very important solutions, and I'm often going to refer to finding the solutions of the equation by saying solve the equation. So when I say solve the equation, what I want to do is find all of the solutions to said equation. Okay, so we'll see examples of this shortly, if that doesn't make sense. So here is sort of the general way that we're going to solve linear equations in this course. Okay, a common method for solving these equations is to replace the original equation by a succession of equivalent equations that have the same solution set until an obvious solution set is found. Okay, so this is what you will probably do without even thinking. Okay, but this is what you're doing in a more technical sense. Okay, there'll be a number of steps to each of these problems, and what you do in each step is you find an equivalent equation that has the same solutions as the previous one, and then you get all the way down to one that is really easy to understand. Okay. In this slide, in the sort of green box, it has common procedures that result in equivalent equations. So, combining like terms, okay, interchanging the two sides of the equation, combining like terms, adding or subtracting the same expression to both sides, or multiplying and dividing by the same expression to both sides, so on and so forth. Okay? And especially if one side is set equal to 0, then factoring may be able to help. These are all things that you'll certainly have practice in doing when we actually solve the equations. So we'll start off with the easiest situation. And the equations that are sort of the easiest to solve are what are called linear equations with one variable, or in one variable. We'll refer to them like that in this course. Okay? It's an equation of the form ax plus b equals 0, okay, where a and b are real numbers. We can solve these types of equations in a few simple steps. So let's look at two examples, one very easy and one a little bit more challenging, of solving linear equations. Okay, and so what you or what someone else has said before is, for these we're solving for x. Okay, and so what we're doing when we're solving for x is we're working down to a form of the equation where the solution set is known. Okay, or is very simple to be known. And we leave no room for doubt because we solve for x and we say that's what it's equal to. So let's solve this equation. So the first thing that I need to do, I'll rewrite the equation down here. 3x plus 12 is equal to 0. Right? And as you know, we need to get x alone on one side. So I first need to subtract 12 from both sides. Okay, again, creating a equivalent equation that has the same solutions, but it's more advantageous in some way. So when I do that, I get 3x is equal to 12. Okay, and then I need to get x alone again. So I do another valid mathematical move. I divide by 3 on both sides, and I get down to the very obvious solution that x is equal to 4. Okay? I'm sorry. I just noticed a mistake. It's 3x is equal to negative 12, not positive 12. Okay, I subtracted 0 minus 12 is negative 12. Again, I divide by 3 on both sides, and I get x is equal to negative 4. Okay, so that's the first part. We solve this. The second part of any of these equations that you need to do is you need to substitute this value back into the original equation to see if it actually makes sense. Okay, so you could have made an error somewhere in these steps over here. And if you did, then your solution is not actually going to work when we plug it back in or substitute it back into the original equation. So when we do that, 3 times negative 4 plus 12, is that really equal to 0? Okay, so when you do the math, it's negative 12 plus 12. Is that equal to 0? 0 equals 0. Yes. Okay, so this is the checking part. This is checking the solutions. And we will always need to check the solutions. Okay? So that's the easy one. Now to the more challenging one. This one on the right. First thing that we need to do is get this equation, each side of the equation, down to its most sort of elemental parts. To do that, we need to use the distributive rule both here and here. Okay? And when we do that, we get 1/2 x, which I can write as x over 2, plus 5/2. Okay, that's distributing the 1/2. Minus 4 equals 2x over 3 minus 1/3. Okay, so then I've just used the distributive rule. The next thing I need to do is combine like terms and get x alone on either side of the equation. So I think the easiest thing to do will be to combine like terms. And what we need to do is find a common denominator. Since I'm working with fractions, and fractions can be often challenging to work with, I want to get all of the fractions and even the whole numbers to have a denominator that is equal. So then I can sort of work everything together. And so I have a denominator of 3 on the right side and 2 on the left side. And so the least common denominator of 2 and 3 is 6. Okay, so if I multiply them together. So what I need to do is create, for each expression, okay, all 5 of them, I need to make it so that they have a denominator of 6. Okay, so to do that, and I'll change color to do that. Here, I need to multiply by 3 over 3. Again, 3 over 3. Here, 6 over 6, because it's really 4 over 1. Over here, I need to multiply by 2 over 2. And here, also by 2 over 2. Okay, again, I can multiply any single expression inside of the larger equation. I can multiply it by 1 because that's a legal move. So I've done it in a sort of clever way so as to not change the value of the expression, but to make it easier to work with. So when I do all that arithmetic, I get 3x over 6, okay, is that first equation, plus 15 over 6, that's the second part, that's 5/2 times 3 over 3, minus 24 over 6, okay, that's from the minus 4 part, equals 4x over 6, okay, comes from that first expression on the right side, minus 2 over 6. Okay, so now I have everything over 6. I'm going to try to put the x's on the right side. So I want x's over here, and then I want just regular numbers over on the left side. Okay, so I'm going to do a bunch of arithmetic to do that. So I need to add 2 over 6 to get that on the left, and I need to subtract 3x minus 6 on both sides to get it right, to get what I want. So I'd add 2 over 6 over here, and again subtract 3x over 6 here. So hopefully we're keeping up. That cancels that. That cancels that. And I'm left with 2/6 plus 15/6 minus 24 over 6 equaling 4x minus 3x over 6, or 4x over 6 minus 3x over 6. Okay, I can now combine, I can add these fractions together because they have a common denominator and combine like terms. Okay, so on the left side I have 2 plus 15, which is 17, minus 24, and 17 minus 24 is negative 7. So I have negative 7/6 on the right side. Okay, and on the left side I have 4x minus 3x, that is 1x over 6. Okay, negative 7/6 is equal to x over 6. So what I need to do is get rid of that 6. So I'm going to multiply both sides by 6, and what happens are these 6's cancel out, and also these cancel out as well, and so I'm left with x equaling negative 7. Okay, so you notice that I flipped the x over to the left side. I can do that because it doesn't change the value. So I have x equaling negative 7. X equaling negative 7. Then I need to check the solutions. I'm going to do that up here. 1/2 negative 7 plus 5 minus 4 is equal to 1/3 2 times negative 7 minus 1. Okay, negative 7 plus 5 is negative 2, divided by 2 is negative 1, minus 4 is negative 5. Okay, so if you're not sure how I did that arithmetic, try to think through it yourself, and if not, use a calculator. And then on the left side, 2 times negative 7 is negative 14, minus 1 is negative 15, and negative 15 divided by 3 is negative 5. So I in fact get negative 5 equaling negative 5. My check is good, and so my solution is negative 7. Okay. Now I know that was a longer process. That would be one of the more challenging questions that you'd have in this section. So let's end this video by a your turn. Okay. It does have fractions involved, but most of the fractions are over 2, so you don't have as much work to do. So I want you to solve the following equation for x. Okay, find the solutions to this equation.